in my civilian life, when I'm doing normal things like taking my kid to play dates or something, and I introduce myself to people and I tell them what I do, I usually get one of two responses, either a blank stare or something along the lines of, cool, I love dinosaurs. Now, I did want to study dinosaurs when I was 5, like I think most 5-year-olds do, but I don't actually study dinosaurs. I hate to disappoint people. I actually study human evolution, because I kind of never really outgrew a lot of the impulses that made me want to study dinosaurs in the first place. But what I ended up studying was Neanderthals, so you can see one here, and you can see I'm really happy about it. Neanderthals are an archaic human species that are probably the only archaic human species that almost everyone in this room knows by name. Now, the timeline of human evolution is about 8 million years long, but Neanderthals only went extinct about 30,000 years ago. And meanwhile, our species is about 200,000 years old. So what that means is that we were kind of like the star-crossed lovers of human evolution. We have archaeological evidence that indicates that we overlapped enough in both time and space that we could have met face to face. And if you follow the science news, then you know that we now have genetic evidence that we definitely did meet face to face, and in a number of other ways. So today, though, modern humans are a very lonely species. We're the only species of our kind left on the planet. And I think that's part of the reason why so many of us are obsessed with things like Sasquatches and Yetis, because if there are really hairy bipedal apes still running around out there somewhere in the woods, I know everyone likes Sasquatches in the Pacific Northwest, then it would mean that we were not really alone on this planet. And I think that that's part of the reason why Neanderthals seem so endlessly fascinating. We know that humans and dinosaurs never actually coexisted, many cartoons notwithstanding, but we also know that our ancestors knew Neanderthals. And this brings to mind all sorts of tantalizing questions, like when our ancestors met Neanderthals and they looked into their eyes, what did they see? Did they see another kind of human? Were we enough alike for them to think of them as other humans? Or were these Ice Age encounters more like really early instances of primatology? Now, the fact that paleoanthropologists even ask questions like this, and we do ask questions like this, only we usually try to sound a little bit more scientific when we do it, makes the study of human evolution very different from the study of the evolution of pretty much any other kind of organism. I mean, you know, as awesome as charismatic as everyone thinks that saber-toothed tigers were, because everyone thinks that, right, because they were awesome, but we don't usually go around thinking about their emotional lives or wondering what they were like. But in contrast, paleoanthropologists are tasked with the mission of reconstructing our evolutionary past and events in as much detail as possible. And that's a pretty tall order when the data that we have to work with are things like stones and bones and the fragmented, decayed genetic remains that we can extract from those bones. Now, we are also at a relative disadvantage compared to scientists in many other fields because we are generally unable to generate data in the lab. We can't put a Neanderthal in a steel cage with a modern human to see if they fight out to the death or if one of them asks the other one out on a date. The way that some scientists can do things like generating chemical reactions in the lab or growing bacteria in petri dishes. So instead, what we do is we collect data through fieldwork. And fieldwork is an incomplete and rather slow sampling process. Although it's also enjoyable because it involves stuff like foreign travel and camping and drinking lots of boxed wine around the fire at night. And field projects can last years, by the way. But despite the fact that we do all this work, at the end of the day, we know that the amount of data that we have is only a painfully small fraction of the total story of our evolutionary history. Our data set remains very, very incomplete. For those of you who are not familiar with American politics, I think you kind of get forced to be here. This is former US Secretary of State Donald Rumsfeld and frequent unintentional prose poet Donald Rumsfeld. He once famously distinguished between known unknowns, and unknown unknowns. The last of which represent those things that we don't know. And what I know is that there is actually a lot of debate over whether this quote is inane or profound. I actually find it kind of profound. I might be kind of biased by what I do, but the thing is that human evolutionary studies are especially vulnerable to revelation, or perturbations due to the discovery of previously unknown unknowns. Now, Neanderthals were the first fossil humans known. They were discovered in the 19th century. And at that time, there were kind of like these rumblings and murmurings about the possibility that species could evolve and change over time. But for the most part, everyone thought that the world was young and that every living thing in the world had been specially created supernaturally exactly as it was. Now, there was a very popular estimate of the date of creation that was established in the 17th century that had the Earth being created on 6 p.m., October 22nd, 4004 BC. And this was the date that everybody went with for hundreds of years. It's still printed in some editions of the Bible. But what this meant was that when the first Neanderthals were discovered, like my friend from Gibraltar here, who was discovered in 1848, they couldn't be interpreted as anything other than kind of robust but otherwise garden variety modern humans. But then, by the time a fossil was discovered in Germany's Neander Valley, which translates to Neanderthal in Germany because Tal means valley, the publication of Charles Darwin's On the Origin of Species was just around the corner. It was published in 1859. And it went a long way towards convincing the biological establishment that biological evolution actually had occurred, although the idea of humans evolving still made a lot of people really nervous. Now, many Western scientists of the time already believed that modern human societies could be ranked in this sort of ascending scale of complexity or an enlightenment from savagery to barbarism to civilization. You can guess who they put in all of these categories. But if you kind of overlay an evolutionary context on top of this, then you can think of Neanderthals as being sort of the uber savages, more primitive than any modern society, even the most backwards according to current thinking, and so therefore more appropriately compared to non-human apes like gorillas, for example. So here we have a scientifically endorsed reconstruction that was printed in the Illustrated London News in 1909, based on a monograph by a French anthropologist named Marcelin Boule. And he endorsed this reconstruction. He felt like this really expressed what he felt about the Neanderthal fossil that he was describing. And so this probably looks kind of familiar to you. He's hairy, he's dark, he's not completely upright, he's got this savage expression on his face, he's got a club in one hand. This is essentially the scientific origin of the club-wielding, knuckle-dragging caveman stereotype that is still with us today. These questions about how human we thought the Neanderthals were and what it might have been like to meet them are kind of fundamental questions in evolutionary biology, in human evolutionary studies, and they have been ever since there have been human evolutionary studies. But at the time that the Neanderthals were discovered, there was no real idea that the eventual recovery of Neanderthal DNA would ever happen. Now, Charles Darwin didn't know anything about genetics, much less the structure of DNA. And then 150 years later, things changed. We have technological advances that allow us to actually extract DNA from fossils. And the first Neanderthal DNA studies, which started being published in 1997, were kind of a bombshell in evolutionary studies. They seemed to definitively exclude Neanderthals from modern human ancestry. For one thing, the samples that they were getting from the Neanderthals were far too different from what they were seeing in modern human populations to consider them to be members of our own species. And on top of that, so-called molecular clock studies seem to indicate that the date of divergence between us and Neanderthals was far too early for them to be counted among our ancestors. And so the genetic data, with its orderly code here and perceived objectivity, was held in strong contrast to the ambiguity and difficulty of interpretation of fossil data. And so together, that was enough to convince many researchers that Neanderthals could not possibly be our ancestors and put to rest any notions that we ever would have interbred with Neanderthals. But those studies were all based on a kind of DNA called mitochondrial DNA. And that is a separate genome that lives in all of your cells that is distinct from the individual or the nuclear genome, which is that genome or that stretch of DNA that essentially makes you you. It's like the blueprint for you. And so you may wonder why scientists were looking at the mitochondrial DNA in the first place and not at the nuclear DNA. And the reason is that it was what they had to work with at the time. the mitochondrial DNA, DNA, like all organic molecules, will decay over time. And mitochondrial DNA is far more likely to survive in fossil samples simply because it is far more abundant to begin with. And on top of that, ancient DNA samples are commonly contaminated by DNA from things like bacteria and fungi and the DNA of modern researchers who have handled the fossils like yours truly. So this further obscures the signal that's already being obscured of the nuclear DNA. But, and you know there was but coming there too, a few years ago, and by within the last few years, I mean like within the past 2 or 3 years, there have been these major technological advances that have allowed us to actually do something that 20 or even 10 years ago, a lot of us would have said was completely impossible to do. And so last year, researchers in Germany published and assembled a complete Neanderthal nuclear genome using the fragmented and decayed samples of DNA that they extracted from this fossil toe bone back here. Now, this is an achievement roughly the equivalent of doing something like reconstructing all of Tolstoy's War and Peace based on the stuff that you got out of the bin of a crosscut shredder. Except the guy who shredded it threw out every other page before he threw it in there, and then threw in several dozen copies of the IKEA catalog and Sky Mall before shredding the whole thing. Except what the researchers had to work with was even worse because War and Peace is only 590,000 words long, and the human genome is 3 billion base pairs long. So the fact that they were able to assemble this genome was astonishing enough, but then what they found when they compared it to modern human genomes was that many modern humans actually carry between 1% and 4% Neanderthal DNA. This is exceedingly strong evidence that we did, in fact, mate with Neanderthals. And that kind of makes it difficult to kick them out of the family. Not only that, but further studies indicate that the Ice Age was actually a very busy place in terms of archaic-modern commingling. And that paints a very more complex picture of all of our past relationships than we previously thought. That one science website summed up thusly. So, yeah. I'm used to these kinds of headlines in my line of work. But anyway, you may wonder exactly how it is that one kind of DNA evidence could seemingly completely contradict another kind of DNA evidence. And there are a lot of answers to that question, but one of the most simple is that when we use different characteristics to reconstruct evolutionary history, sometimes different characteristics give us different stories. So, for example, we can take digit number. Humans have 5 digits on each appendage. We have 5 fingers and 5 toes. You can't see mine, but you have to take my word for it. Geckos also have 5 toes on each foot, but horses only have 1. So going by digit number, you would think that perhaps Donald Rumsfeld is more closely related to a gecko than to a horse. However, on the basis of the preponderance of information, which indicates that, all of those things that make mammals mammals, we know that Donald Rumsfeld is actually not more closely related to reptiles. And so here in Neanderthal DNA, we have the case where new data basically changed a misinterpretation that was originally made in the context of incomplete data. And that's the way that science is supposed to work. Now, I know that many people find the shifting nature of the human evolutionary story very unsatisfying. Science isn't supposed to change. It's supposed to be about hard facts. It's supposed to be about truths. And the truth is supposed to remain the same. But I think this also may explain why public opinion polls say things like that 4 out of 5 Americans believe that science is valuable and they're really interested in new scientific discoveries, but if you put them on the spot about specific discoveries and findings, they often resist or have difficulty believing them. Like 42% of Americans don't believe in evolution, or 54% of Americans believe in a supernatural explanation for the universe. 51% don't think there was ever a Big Bang. I'm not even going to get into the stats on vaccine safety and climate change because that's just depressing. But I think that some of the reason why people have such a hard time with this is is because of the uncertainty that's inherent in the way that science works. And this is a problem for a lot of people because people are emotionally invested in Neanderthals. When we ask these sorts of slippery questions about what it means to be human and language and culture and things like that, then they really feel like if these answers are uncertain, then it leaves us with uncertainty about our own natures. You know, the news that dinosaurs had feathers probably rocked the world of a lot of aspiring dinosaur paleontologists. It certainly did mine, because when you think of T-Rex as a giant chicken, things are just not really the same after that. But you don't see emotional reactions like this one. You know, like feathered dinosaurs don't make you start rethinking man's inhumanity to man. So the fact is that a lot of the things that we want to know about Neanderthals are things that we might very well never know. Like, what would happen if I sat down next to this guy at the bus stop and asked if I was done with that paper, and could I read it if he was done? Would he attack me? Would he ask me out on a date? I don't know. But I have a colleague who answers a lot of those kinds of questions with, well, I don't know, get me a time machine and I'll tell you. But people don't really want to hear that. And even paleoanthropologists don't want to hear that. We want to know the answers, otherwise we wouldn't have gone into this line of work in the first place. So instead, we keep on working, incrementally making progress, finding new data, hoping that this new data will give us new insights into Neanderthals. And sometimes those insights are so new that they change everything that we originally thought about them. And this is the way that science is supposed to work. I am personally very excited to see what's on the next page of the story. Thank you.